I told Maven project in the first class, right? Just I'll share my screen. So if you create a Maven project, I told you again, Maven is a separate topic in our Maven is a separate course. I mean, separate tool, not course. Sorry, in this course, separate tool actually. This one. Okay. So I'll be going in deep, but now we will see. This is our order. After completing JUnit, Mockito, the third tool I'll cover is Maven. So any project that we start or we build, that will use Maven. In the first session, I told like how we can create a, use Maven project, and then in form.xml, what I do is we use this dependency, JUnit Jupyter dependency. Okay. So we use this dependency JUnit Jupyter. So this when we add this dependency here, it will download, your Maven will download that JUnit jars here. And how Maven will download, I'll tell you when I explain you Maven 2. Okay, everyone is able to hear me, right? Everyone is able to hear me, right? Okay, good. Okay. So now what I will do is, in yesterday's program, we have seen a simple class. We have written a class with a method taking two integers and returning x plus y. That is, this method will add two numbers. Similarly, this method will multiply two numbers. And we have written unit test case to this. In unit test case, what we'll do, unit test case will not be written in the same file. We should have a clear modularity. You know what is modularity, right? Modularity means your source code. This is your source code. What is a source code? The program or the code which performs the business logic. This is your business logic, right? In my program, I'm doing a simple addition, simple multiplication. This is my business logic. Okay, but in some real-time programs, I will do some more complex things. Like I want to develop a bank project. I'll do some banking operations. All that banking operations I will write. Okay, but now this is simple logic, addition and multiplication. Now the test case where I will write in a separate file. I will write in a separate test file, which is called apt-test.java. So here what I'll do is, here I will write two test methods, one for testing add method and another testing product method. So what are the steps in unit testing? First, we'll define the input to be passed. we'll define expected output, then get the actual output. How we get the actual output? When we pass the input and call the method from the class object, we get the actual output. Now we use asset equals. This is a part of your JUnit. This method is a part of your JUnit library. So asset means validate or judge. Okay. That judge that expected output should be equal to actual output. In case if expected output is matching with the actual output, then this test case is passed. Otherwise, if expected output is not equal to actual output, this test case will be failed. What is the test case? This method. Any method that is annotated with @test. This is called test method. Similarly, we'll write one more method for product. Okay, here we call product method. And here also we'll define the expected input, the expected output, okay, actual output, and then writing asset equals with expected output and actual output. Very simple, right? See, if you know this simple way of doing, you can do this for the same process for the complex logics also. Okay. Now, why can't we write the same code in this only? Because see, our test case should be separate from the source code. This is your test code. This is your test code. And this is your source code. So we should have a clear separation. And one more thing is, why we are using this asset equal. See, if we don't use this, we can write in another way also, where we can use if else statement. If expected output equal to actual output, but that is not the correct way to do. When we write the test case in JUnit, we have to use these kind of things. What will happen is, these are a part of your JUnit actually. See, JUnit Jupyter assertions dot asset equals. Like that, there are so many asset statements. Okay. I'll show you what are those asset things. We'll see when we study the examples. Okay. Now, okay. Now, we will see one more example, one more small project. That is another project I'll do. I will create a project file new Maven project. Again, I'll create a Maven project. I'll select this quick start. What this quick start will do, it will create a project structure like how it has been created for the earlier project. Click on next. JUnit demo 2. com.JUnit demo 2 finish. Okay. You can take a running notes always. What I'll tell you, suggest is, I suggest you take a running notes and start writing whatever I tell. That is what we call running notes. Okay. See here, if you see, Yesterday I told I'll upload these notes also to in the Google Classroom notes. Yes, I think last session I told all these notes to you. Okay. Like define some input to be passed, define expected output, invoke the method, get the actual output, compare expected output and the actual output. If expected output is matching that, then test case is pass, else fail. Like that. I'll ask actually. I also don't have Google Classroom link. I'll get that from admin and I will upload that in this all these notes to everyone. Okay. Now, JUnit has assertion statements. So these assertion statements will validate or judge the output. Okay, examples we'll see. Assert equals expected output. Assert equals expected output, comma actual output. So what assert equals tells? So if expected output is equal to actual output, so this is passed. I mean, assert equals will make test case passed. Test method, test case or method passed. Instead of test case, I'll say test case passed. I'll tell you what is test case. Test case and test method. In a test method, see, for example, I'll tell you one scenario. This is your test method. This is your test method. This is your test method. Inside this test method, this is test method. Inside, this is your test method. So inside this test method, this is a test case actually. So inside a test method, I can have multiple. So inside a test method, so inside a test method, we can have multiple test cases. Okay. Now, for example, I can write one test case like this. I can also write one more test case. I can also write one more test case like assert not null of actual output. So what is this means? This will check if actual output is not null value. If it is not null value, then this test case is passed. Else it will throw error. Is passed. What you mean by else means if it is null value, then this is failed. That means in the same test method, I can have one more test case. In the same test method, I can have no, this is one test case. This is another test case. So this will compare expected output, actual output. This will compare if the actual output is not a null value. Okay. So one test method can contain multiple test cases. One test method can contain multiple test cases. Okay. Now, similarly, this is one test method. I can have multiple test methods in a single test class. See, for example, this is your test method. This is again another test method. I can have multiple test methods. So that means in a test class, I can have multiple test methods. Multiple test methods. Test method. Okay, multiple test method. Okay. Now, in a test method, I can have multiple test cases. Multiple test cases. Okay, like this second, right? Okay. Okay, like this. Okay. So this test method can test for one business method. This test method can test for one business method. So what do you mean by business method? In our earlier example, we have int add, this is for one business method. Okay, this is another, this will test another business method. Okay, like that. Now under this testing one method, we will have multiple test cases. Like one test case will check. One test case will check for output null value or not. Well, you are not. Okay. Another test case. Check for expected output equal to actual output. Like that. Right? Like that. Okay. Fine. So like that. Okay. Now, for this, we use in JUnit asset not null. And for this, we use in JUnit asset equals. Okay. You can take the running notes, whatever I tell. Very, very important. Running notes is most important. Okay. Don't. I suggest that, see, this is all online sessions, right? If it is an offline session, I can watch you, how you are listening. Since it is an online session, I cannot watch you. So don't relax and listen. Listen with concentration. Take a paper, pen, and write the note. That is the way we have to learn any course. Okay. Don't relax and listen. If you relax and listen, after this class, you will forget again everything, whatever I do. Okay. Anyway, I'm going to upload all these notes. But before I upload, you also should take a rough paper or notes, not rough paper. You have to take some, again, rough paper, you will again tear it out. You have to preserve that in a notes actually. Okay. Find them. Now we will see one more. Now we'll see with some what you say, some real-time scenario. Okay, some real-time scenario. See, whatever we have seen is a simple ad and simple product, just adding two numbers. We are testing these two. Now what I'll do is, okay, I created a Maven project, right? And in form.xml, copy this dependency. Copy this dependency. Okay. Copy this dependency. Because we are using JUnit 5. And you have to change from 1.5 to 17 version. So right click on the properties, Java build path, then remove, add library, JRE system library and JDK 17. Click on finish, Java compiler. Next is 17, apply and close. Fine. How I changed this from 1.5 to version? Again, I'm showing. Right click on properties, Java build path. Okay. Here I already added. You have to click, or I'll remove this. Add library, JRE system library. Select JDK 17. Okay, because JDK 17 is the latest version. Java compiler 17, JDK 17. Apply and close. It will change to 17. Okay. Now, I will write one simple. Now we are going to develop small develop Java code components or class components for a customer management system. Okay, for a customer management system. Let us say there is an organization called Airtel. There is an organization called Airtel. Okay. In this organization, we will develop an application that will add customers, that will add or register customers. Okay. Okay, we'll develop an organized application that will add or register customers. So here we are not going to use any database or anything. We are going to use Java collections. How many of you know Java collections? Very simple. Hash map or array list. How many of you know this? How many of you know? Okay, good. For those who don't know, I'll give some brief ideas. Everyone knows what is a database, right? Let us think. You have a computer. So this is your computer. Okay. In computer, we have mainly three parts. One is secondary memory. We also call this as hard disk. We also call this as hard disk. There is one more component called primary memory. Primary memory. This we call it as a RAM. This we call it as RAM. Okay. And there is one more component called CPU. Central Processing Unit. So this contains some components like ALU, which is called arithmetic logic unit. Right? This is CPU, which is central processing unit. And this is ALU, which is arithmetic logic. Okay. Inside this. And in addition to that, you have some registers also. CPU also will contain some registers. Registers, okay? Okay, registers. So CPU does all the calculations, all your logic, all the calculations will be done here. Okay, in this computer, you'll have one more very important component, which is called operating system. Operating system. Okay. In this computer, we have one more component called operating system. Now, okay. So you install Java software. You will install Java software in this machine. How will you install? Through operating system. Without operating system, you cannot install it. And what will happen is, in the secondary memory, your hard disk, your Java software is stored. Software is stored after installation. Okay. Now, when you develop a .java file, you will write a .java file, right? Some a.java or b.java. These are your Java files. So these files will be saved in hard disk. Your hard disk is your C drive or D drive, right? Now, when you compile these files, when you use IDEs like Eclipse, they get automatically compiled. But when you go for a command prompt, you use Java C A.java, Java C B.java. You will compile these files, right? So these files are converted to .class files, like A.class, B.class. So these also will be stored in hard disk. These also in hard disk, okay? C drive or D drive. So these class files also stored in their own hard disk, C drive or D drive, right? Now, when you now type Java space here, what do you mean by this? This is running. This is compiling, and this is running the Java program. What will happen, you know? Your Java software contains compiler plus there is a concept called JVM, Java Virtual Machine, which is your where your Java Virtual Machine will convert this .class file, into machine code, and where that machine code will be executed by your CPU. Okay. Now, what will happen is this Java Virtual Machine will be, whenever you type this command Java A, your Java Virtual Machine will be loaded in the RAM. Your operating system, what it will do? It will take the JVM from your hard disk and load in your RAM in primary memory. Okay, your JVM gets loaded in RAM. Okay, and what JVM will do? So this is when you type Java A. So JVM will read. Okay, read byte by byte, or we can say like this. Read line by line. We can say line by line of .class file and convert to machine code. Machine code which is stored in RAM. Which is stored in RAM. Now, from there, what will happen? There will be a bus, a system bus, that will take this machine code which is stored in RAM and load in CPU for any execution. And again, the result will be again stored in the bus. That result again will be copied to RAM, and RAM will have all that result. Fine. Now you see why I told all this is your Java will be having in your Java program, you will be using okay, objects, variables, right? Again, in objects we'll have, there are so many objects. In objects, there might be custom defined objects. Next, Java collection objects. Okay, file objects. So many objects will be there, right? We'll be using, depending on our requirement, we'll be using all this. So all these objects, variables, everything will be stored in RAM, in your primary memory. Okay. And one thing you have to remember. Okay. One thing you have to remember, the data that is stored in hard disk is permanent. The data that is stored in hard disk is permanent. The data that is stored in RAM is volatile. The data that is stored in RAM is volatile. Volatile means once your Java program is done, the data gets deleted. Or once your system gets shut down, the data gets deleted. Okay. If application shutdowns, data get removed from RAM. Right? Now, your data that is stored in the hard disk is permanent. Even if you shut down your system and again restart the system, whatever your file stored in your C drive or D drive, that will be there like that, right? Okay. Now, all your objects, variables which are running in Java program will be stored in RAM only. Once the Java program is done, all these objects gets deleted. But you want to store some the data permanently somewhere. So that is where hard disk comes. So in the real world, what we do is we use database. Suppose you have an application. Okay. Your database will be stored in the hard disk. Your database. Okay. Your database will be stored in the hard disk. And your Java collections or any other Java objects that will be stored in RAM. Java collections, okay, or objects, okay, will be stored in RAM. Okay. But RAM data is temporary only. RAM data is temporary. The data in RAM will exist as long as program is running. Once program shuts down or gets completed, data will be removed from RAM. Okay. But data in hard disk will be permanent. So since database is in hard disk, is in hard disk, data can be stored permanently in database. Okay. So data can be stored in permanently in database. Okay. Now, what I tell you is, I will write a program now where we will develop an application that will add or register customers. Okay. We will write to develop an application. Now, for this, to add or register customers, we can store the data in data hard disk, or I can store that in Java collections. For now, for demonstration, I will not use database because it's a temporary. I'm not developing a permanent application. So just to develop the unit test case, just to show you the unit test case, to add this, I'll store this data in the RAM. Okay, that is Java collections. That is, I'll use Java collections and store here. Okay, I'll not use database because I'm not going to develop a permanent application. Okay, I'm going to just show you for this how we can write this one. Okay. Now I'll add this. I'll use collections and store here. Okay. Now, we'll write the program now, and then we'll start writing the unit test. So what I'll do is new. I'll write one class called customer manager. I'll write one class called customer manager. Now, I'm not going to use a database. I'm going to use Java collections to store the data, to store these customers. When I add or register customers, all the customer data will be stored in collections. So for that, I use a data structure called hash map. So what is a hash map? Hash map stores the data in the form of key value pair. In the form of key value pair. Okay, now let us do that. So what I'll do is, so I should have a customer object. What is the data I'm going to store? I'm going to store customer object. So I'm going to store customer object. So value is a customer object. Customer object. Customer object. Okay. So for that, I should create a class called customer. New class customer. So for this, now I'll use string ID. Next, string first name. Next is string last name. And I'll use the phone number. Okay. Okay, this is the data. So let me generate setters and getters for this. Source generate. See, if you go to Eclipse, right, you can easily generate setters and getters. See, why we are using these private variables? You might have studied about encapsulation, right? What is encapsulating that? So you have to use private variables and methods will be public. Source generate getters and setters. Select all, generate. So Control X. Okay, that's all. Okay. So this is your customer. Now, in your customer manager, what I'll do is I'll create a hash map that takes string as a key and customer object. I'll say customer data is equal to new hash map string customer. Okay. As I told you, I'll be storing the data in hash map, not in the database. If it is a real application, really I will store the data in the database. Okay. Now, So this will be part of your java.build.map, java.build. I'll also write one more thing, private static string organization name is equal to Airtel. Okay. Then what I'll do is I will generate only customer methods for this, the getter methods only. Source generate getters. Only select getters and generate. Okay. I got now get customer data, get organization. Okay. Now, because these methods I have to call from outside. That's why I have put this as public. From outside class also I have to call these methods. Now, what is our application does? Adding or registering customers. That is what our does, right? So what I'll do, public customer, add customer of, I'll say string customer ID, string first name, string last name. Okay. String phone number. Like this. So these are the data I have to customer ID, because customer contains, these are the properties of customer, right? Customer ID, first name, last name, phone number. So now what I'll do, I'll create a customer object is equal to new customer, because I have to store, I have to take this data, set in the customer object and store this customer object in the hash map. That's what I'm doing. So now customer dot set first name, customer dot set last name, customer dot set set ID is also there, right? Yes, customer ID. First I'll write that one. Next, customer dot set phone number. Then what I'll say, return customer. And when I add customer, where I have to add? I have to add in the map. I have to add in the map. So what I'll do, I'll say customer data dot put of ID comma customer. So this is what I'm doing here. Customer ID comma this. So this is what I'm doing. So what I'm doing here, see, this method will be called from outside. Say, for example, here I'll write the program. Customer manager is equal to new customer manager. Manager dot add customer. I'll say C100. I have to pass the data C100 customer ID, first name. Okay. Ramesh Kumar and phone number. I'll use something like this. Some dummy number. Okay. This is your mobile number. Similarly, I can add some 4 or 5 customers. C200, C300, C400, C500. So I'll say Ravi Babu. something like some dummy number, some Sekar Babu, some dummy number, okay, some Krishna Kumar, something like this, okay. I'll say John David, something like this. That's all. So what will happen, you see now? What will happen, you see? When I call this is the main program, right? So when I call this, you see, and this is the map. So if you see, this is an instance map. You see, this is an instance. Now you see, this is an instance data. I mean, instance variable, instance object. Now this will be created when this object is getting created, because this is a part of your customer manager, right? This is present where this code is present where this is part of your customer manager. So what I'm doing now, whenever the object is created, this hash map gets created. Now when I say manager.add customer, that means this method. So this method gets called. In this, what I'm passing? Customer ID, first name, last name, phone number. And what we are doing now, see, when first line is called, when customer manager updated, hash map is created. In your RAM, this is your hash map in your RAM. Okay, hash map empty object is created. Now when I call this line, this method gets called. And here what we are doing, we are creating a customer object and setting all these properties. And then we are customer data.put, we are putting customer ID and customer. What is your customer ID? C100. Your customer ID is C100. And the value is what? This value is a customer object. This value is a customer object pointing to customer object. So which has properties C100, Ramesh, Kumar, and what is a phone number? Phone number is 368455558. Okay. Similarly, when second line is called, in the same hash map only, a new entry will be created, which is your C200. Which is your C200. And here there will be an object created again with properties C200. C200, Ravi Babu. Next 8, 5, 7, 5, 8, 5, 6 like this. Okay, like this. Similarly, when third entry gets one third, you'll add a 300, another object, C300. Similarly, when fourth call happens, C400. This is again another object. When fifth call happens, C5. In this way, we are storing this data in the memory. But once the program gets terminated, this memory data also gets deleted. That is the reason I told you between memory and hard disk. Okay? Fine? Everyone understood this logic now? Now here what I'll do is, I will write one more method. Get all customers from data store. Here, what is your data store or data store? Your hash map, right? This is your hash map. Okay, what we'll do? Public collection customer get all customers. So return customer data dot values. Okay. Okay. Now what I'll do is, after adding this, I'll say manager dot get all customers dot size. I'll get int customer data size or customer count. And here I'll say system dot out dot println customer count. Let me run this program. So you got count as 5. That means 5 records. If you see 1, 2, 3, 4, 5, 5 records. Okay. Similarly, I will also write one more method. Yeah. Here, what I'll do is, everyone understood, right? Everyone clear? Whatever I'm writing. All right then. So what I'll do is, see, before adding the data to customer, I'll check whether if customer already exists. I'll just say customer. Check if customer already exists. Okay. But then here what I'll do, private void check if already customer exists. Customer. Here I can pass customer ID. Now what I'll say, if customer data dot contains key of ID, here I'll say string customer ID. Customer ID. Then I'll just say throw new runtime exception of customer already present. Like this. So throw new runtime exception, customer already present. You understood, right? What I'm telling, what I'm doing. Suppose now I have this data. Now I'm trying to add one more call like this. Manager dot add customer. I'm trying to add C200. C200 is what? Ravi Babu, right? Ravi Babu. And so mobile number. Okay, like this. So whenever I add it like this, now it will see whether C200 is already present. Yes, it is already present. If it is already present, it will not take. It will throw an exception. It will throw an exception that customer already present. That's what I'm doing. Customer data contains key. Contains key is a method in hash map which will check whether this customer ID already present in the data in the hash map. If it is present, we are throwing an exception. So that is what we are doing. If it is not throwing an exception, then it will take the data. It will go and insert the data. If it is throwing an exception, it will come back from here only. It will not go to this method. If it is throwing an exception at this place, it will come back. It will return from the method. It will not go to this place at all. In this way, we are doing. Now, what I'll do is tomorrow, we will write the unit test case for all this. We'll write using JUnit how we can test all these methods. This is the business logic. Tomorrow, we are going to write the unit testing. Everyone clear? Understood? So tomorrow, we are going to write unit tests for this customer manager. So you should know basics of Java. As I told in the first session, some of the tools we are studying, Java is the prerequisite. Basics of Java, you should know what is hash map, what is how we'll write a methods like this. You should know all that. Okay. Just let me know yes if you are clear with this program. Who tells yes, clear with this program? Tomorrow I'm going to write unit test for all this. Oh, very good. I see a lot of yes coming. Very good. Very good. You understood, everyone. Very good. Excellent. Very good. Yeah, I see so many yeses. Very good. Excellent. Okay. So tomorrow we are going to write JUnit for all these methods for this class. All right then. Okay. See you tomorrow.